Good morning. This video is for Algebra 1, Period 3, Lessons 2 and 3. That we're going to talk about Lesson 1 real briefly. But first, a quote. Normally, it is not polite to go into someone's room without knocking, but you can make an exception if the person is dead or pretending to be dead. That came from Lemony Snicket's Horseradish, but it's truths you can't avoid, page 126. All right, Lesson 1, just a quickie. If you're graphing inequalities, you're usually graphing them on a number line. When we start graphing linear inequalities, we're going to graph them on a coordinate plane, but that's because they're linear inequalities. All right, so A is less than 1 on a number line. That looks like all of the numbers less than 1 but does not include 1. So we use an open circle when it doesn't include 1, and all the numbers that are less than 1 are going to have the arrow above them. And then what number is the arrow is above or shows that they're above or continues to show that they're above because of the arrow is what A could be. A could be 0, it could be -1, A could be 0.9999998, as long as it doesn't include 1 or anything larger than 1. When you're talking about n is greater than or equal to -3, in this case, n could be 3, so we have to include -3 into the situation. So on the number line, we're going to say includes 3, and we use a closed circle for that, and then all of the numbers greater than 3 have the arrow. There we go. All right, moving on. All right, this is lesson 2. So this is just a reminder that anything we do on one side of inequality or inequality has to be done to the opposite side as well. So if I'm trying to get m by itself, I'm going to add 6 on both sides. So if I add 6 on both sides, I'm going to get m is greater than 2, because -4 plus 6 is 2. All right, and then if you need to graph it, look on the previous slide. All right, next up, we have t plus 3 is greater than 8. So if we need to get t by itself, we're going to subtract 3 on both sides, and that's going to give us t is greater than or equal to 5. Again, graphing's on the previous slide. All right, equivalent inequalities. They look different but mean the same amount. So if I go ahead and simplify the stuff on the right, which is the 7 is greater than x plus 4, I'm going to subtract 4 on both sides, and I'm going to get x is greater than, or excuse me, 3 is greater than x, which is the equivalent of 3 is greater than x. So these are equivalent inequalities, but I'm really saying that the top part is the equivalent inequalities. Okay, there you go. So those are why they're equivalent, okay? Because if you simplify one, you're going to get the other, or if you simplify both, you're going to end up with the same result, which makes them equivalent. All right, last slide. Let's talk about why when you multiply or divide an inequality on both sides of the inequality by a negative number, you have to flip the direction of the inequality. All right, and this is the multiplication and division properties of inequalities. So if I multiply both sides here by -1, excuse me, before I even get to that, you guys all agree that 7 is greater than 5, right? If I have 7 cookies compared to 5 cookies, I have more cookies if I have 7 cookies compared to 5. Hopefully you agree. Okay, but if I multiply the situation by -1, is it still true? So then I end up with -7 is greater than -5, which is false. -7 is not greater than -5. -7 is further from 0, but because it's further from 0 on the left side of a number line, it is actually less than -5. So you actually have to switch the direction of the inequalities to make it true. This is the same for any inequality situation where you have to multiply or divide by a negative number and you have a variable. Okay, so just because the variable's there doesn't mean you suddenly don't start flipping things. And if you've had me before, you know that flipping the inequality is what I call flippage. So if I say don't forget flippage, it means that you need to remember that you need to flip the direction of the inequality for a particular problem. Okay, adding and subtracting a negative number doesn't have this situation going on. It's only when you're multiplying or dividing by a negative number. So let's go ahead and take a quick example. We have -k divided by 4 is greater than -1. Okay, so we need to figure out what k is. To do that, what's the opposite of division? Was multiplication. So we're going to multiply by -4 on both sides. to get k is less than 4. So if k is less than 4, and I already did flippage for you, there's the flippage for you. Let's go ahead and check. So if k has to be less than 4 to make the situation work, let's try plugging in 3. 3 is less than 4. So we've got negative 3 over 4 is greater than negative 1, which is true. Negative 3 over 4 is closer to 0 than negative 1 is, which means it's greater in this case because it's on the left side of the number line. Okay, so let's try a number that's greater than 4. Let's try 5. Well, when k is 5, we've got negative 5 over 4, which is greater than negative 1. Well, that's false. Well, negative 1 and 1/4 is not greater than negative 1 because it's further from 0, it's on the left, than 1 is. It's further on the left than negative 1 is, which means it is actually smaller in value than negative 1. All right, really short lesson today, guys. Have a good weekend because I'm recording this on a Friday. If it's not a Friday, so sad. Yeah, see you guys later. Bye.